All right, so our critical points are where your derivative is 0 or undefined. Most of the time we talk about 0, but undefined is technically going to give you a critical point as well. So just don't forget about those. And they are candidates for locations of relative maximums or minimums. I'm going to let you write that and then talk about that real quick because it's a lot of vocabulary going on. Candidates means they might be, and they also might not be. The one that I bring up all the time is the x cubed graph. Here, just look at this real quick. Do you see how for x cubed, this is a critical point. You're get a horizontal tangent line there. Do you get what I'm saying? But it's not a maximum or minimum. They're just candidates. They're what could give you a maximum or minimum. Also, and this is what people like mix up all the time, and they will not give it to you. Like they will correct your grammar and be really picky about it. They are locations of relative maximums or minimums. They are the x value. If you say the maximum is the critical point, they will not give that to you. Okay. So do you remember how we write maximums and minimums? Y at x equals whatever. That's how come we do that. All right. So here's our first derivative test. If f prime changes from positive to negative, and I want us to think back to, do you remember the envelope activity? Feels like a million years ago, where you matched up the f of x graphs and the f prime graphs, and it was like positive above, negative below. Do you remember above sea level, below sea level, all that stuff? Okay. So if your f prime changes from positive to negative, that means your f of x changes from increasing to decreasing. And so that would give you a location of a what? Relative maximum. So location of relative maximum. Location of, it's the x value. It's not the maximum itself. You would have to plug back in and get a y value for that. But if f prime changes from positive to negative, that is the location where you get a relative maximum. And then I call this the sibling statement. It's going to be the same thing, but the other way around. If the derivative changes from negative to positive, so if the derivative changes from negative to positive, that means your f of x graph changes from what to what? Decreasing to increasing, and that is the location of a relative minimum. Good. So location of relative minimum. Positive to negative maximum, negative to positive minimum. Now we wrote out this little chart when we did velocity and acceleration. It just says f and f prime now. But you want to write this down. You're going to write it like at the top of your paper and everything that you do from now on. Increasing positive, decreasing negative. And we're going to add to that little chart when we get to the second derivative test, which will be next time. And then what I'm going to do is give you all a little sticky note. And you can write it down and then just bring your sticky note with you for everything you do. You cannot use your sticky note on the test, but you can write that as soon as you get your test. Okay? Because you can't go into the AP exam with a sticky note. So state the intervals of increasing and decreasing, and the extrema means maximums or minimums. So the relative maximums or minimums, justify your answers. We're going to write a whole bunch of sentences. Okay. The first thing you're going to need if you want to use the first derivative test is to get a first derivative. Write kind of small. You're going to write a lot here. What is your first derivative? Good. 3x squared plus 6x. Good. We're going to set that equal to 0 so we can get our critical points. What algebra would you do there? Like, right, factor out. Good. That would leave you with x plus 2. And so what are your two critical points? 0 and -2. So those are your critical points. If you get asked for the critical points, that's those. Now you need signs, positive and negative, for your first derivative. Positive and negative is what we need to look at. So you're going to make a number line for the 3x. Do you remember doing this with velocity and acceleration? It's the same thing. Just instead of velocity, we're just calling it f prime, right? And then x plus 2. So this one's going to change at -2. This one's going to change at 0. If nothing weird or backwards happened, like if you don't have a squared or a negative or, you know, nothing strange, how can you fill in your number lines? It'll be negative to positive, and it is going to alternate, right? So negative to positive for both of these. If that bothered you, you can always pick a test number. Get a number smaller than 0, plug it in. Get a number bigger than 0, plug it in. Same thing for -2. And then you're going to slice up your number line. What is the overall sign for the first section? Good. Negatives cancel. So we have positive, and then this will be negative, and then positive. We're going to write 4 sentences for every single one of these. We're going to talk about increasing, decreasing, relative maximum, relative minimum. Those are the 4 sentences, okay? Your sentence starts, f of x is, or f of x has. F of x is the subject of your sentence. We together there? F of x is, or f of x has. When you do the justify part, like the because part, the source you're citing is the first derivative. You know how if you like cite a source in English or whatever, like you're quoting somebody, that's your first derivative. He's the person you're citing, right? So we're going to say f of x is increasing on what intervals do you think? Look at the number line we just did. -∞ to -2. Union. Where else? Good. Why? Because now we're going to say because. Who's our source that we're citing? F prime. If you say it, they will not give it to you. If you say it, they will not give it to you because you have an F, you have an F prime, and you have an F double prime, and you have to say which one it is. This is your source because F prime is what? Is positive there. That's your justification. And that won't change. It is a definition. So if you want to justify increasing, it's because F prime is positive there. It will not change. That's the answer. On your AP exam, that's the answer. All right, here's the sibling statement. F of x is decreasing on what interval? -2 to 0, because who's your source? F, don't say it, they won't give it to you. Because F prime is negative there. Now we're going to do the relative maximums and minimums. We're going to do 4 sentences for each of these. So this one, instead of f of x is, it's going to be f of x has a relative maximum at x equals. You can't say the maximum is that number. It's the location of. But if you remember to start your sentence, f of x is or f of x has, you won't get it wrong. Start it, f of x is or f of x has. You're like, why is she saying the same thing? Because if I say it enough times, it'll be ingrained in there, right? F of x has a relative maximum at. Do you think it's the -2 or do you think it's the 0? Because there's not like it could be either. There's a right one and a wrong. Maximum. Why is it the -2? It's because f prime does what there? Switches from what to what specifically? Positive to negative means relative maximum. And you can draw this if you want. Increasing to decreasing, positive to negative, and see that it's a maximum. Because f prime changes from positive to negative there. And then kind of like the sibling statement to that, f of x has a relative minimum at x equals what? 0? Because who's your source? F prime does what? Yep, changes or switches is fine. Changes from negative to positive there. That is essentially all the information. Those are all the definitions. Okay, we're just going to practice it a few more times. Okay. All right, so for this next one, we're going to do the exact same process, but it'll actually be less work because you don't have to take a derivative and factor it and do a number line and all of that stuff. You're just going to use this graph right here. Now be really careful. Do you see how it's the graph of f prime? This is your derivative. Most of the time they give you the derivative graph. That is, it is like 9 out of 10 times, that's the graph that they're going to give you. So I guess you can turn that into a number line if you want to, but I would just look at above sea level and below sea level. So just watch me point to this. Do you see how for this portion, the derivative is positive, and this portion, the derivative is positive? Because derivative is positive there. And then do you see how for these portions, the derivative is negative? Okay, I would try to color code it, but the colors won't show up there anyway. I guess you could get out a pen and color code them if you want. Next thing I would do is look for the critical points. What do you think are our critical points? And hint, there's quite a few of them. The origin is one of us, is 0. What else? 2, good. What else? 4 and 7. So we have 4 critical points. So those are our critical points. Now we're going to write out the same sentences. F of x is increasing on what intervals do you think? And I'm just going to draw a line to separate this from the other problem. You're going to have to write pretty small here. This is going to... Oh, good. 0 to 2, increasing 0 to 2, union. It's actually 4 to infinity. That 7, there's no change there. It's going to stay above sea level. Good. You guys got that. F of x is increasing. You're talking about f of x, and you don't have the graph of f of x. You have the graph of f prime. So you're making statements about a graph that is not the one you're looking at. It's tricky. All right, f of x is increasing on these intervals because who's your source? All right, because f prime is positive there. I'm going to just try and fit that in so I can fit all my sentences. I should learn to write smaller. All right, the sibling statement. F of x is decreasing, wherever the derivative is negative, so below sea level. So that would be negative infinity to 0, good. And union to, good, you guys have got this. Because f prime is negative there. Again, those justifications aren't going to change. That's why I just drill them and you get used to writing them. And then that word justify doesn't seem so scary anymore. Is my goal with this. I just say it over and over and over and over and over.
I was going to ask.
Yeah, go ahead.
But you said they won't ask all of them.
No, they'll typically ask, where is f of x increasing? And you would just have that one. Or where does f of x have a relative minimum? And it would just be that one. I'm teaching you the topic though, so we're doing them all. Okay. Cool. Because they might ask you any of them, so I have to teach you all of them.
To write it like paragraph style or like this?
It'll just be one sentence. Yeah, they're only going to ask you one. That's so cool. You guys are asking me that. You're the first people to ever ask me that. I've been doing this a decade. People are just like, okay. You guys are actually thinking. It's cool. All right. F of x has a relative maximum. Now that would be where the derivative changes from what to what? Maximum. Positive to negative. Now that would be above sea level to below sea level. So where does that happen? Good. Do you guys see that it too? It changes from, I said it, I shouldn't have done that. F prime changes from above to below. All right. Relative maximum at x equals 2 because f prime is your source that you're citing. That's like your bibliography. All right. Changes from positive to negative there. Yes, can you hold on though? Because everyone writes at different speeds and I don't want to get ahead of everybody. All right, so now we're going to do relative minimum. F of x has a relative minimum at x equals. Now that would be when the derivative changes from what to what? Good, so that's below to above. And there are 2 places that happens. So you just say both of them in the one sentence. You don't have to write another sentence. At x equals 0 and x equals 4 because f prime changes from negative to positive there. And I hate to break it to you, but there's one last sentence. Because sometimes they will make you write a sentence about each critical point, and there's one critical point that we didn't say anything about yet. So which one didn't we mention? 7. So f of x has what going on at 7? Bounces there, so the derivative does not change sign. So would there be a relative maximum or minimum? No, and this is what I was saying about them being candidates. Still a critical point, but it didn't give us a location of a relative maximum or minimum. So we're going to say f of x has neither at x equals 7. And how would you word that? There's a few ways you can say that. Like, how would you put that in your own words? Because f prime, you could say because f prime does not cross the x-axis. What else could you say? Good, but say f prime. F prime doesn't change sign. I know you guys are going to think I'm being so hateful. I just want you to get all your points. I don't want to write ACK on anyone's test. And then there's one other thing that I sometimes get people to say. F prime stays above or F prime stays positive. Those are all acceptable. Okay. I'm going to write because F prime doesn't change sign there. That's my preference. Because if justifying that there is one is a change in sign, to say that there's not one, I say doesn't change sign. But again, any of those other things we mentioned are all acceptable, just different ways of saying the same thing. Yes, B/C is because B/W is between. Yep, they'll take all those. I would put the slash. BC, I mean, I would accept it. These are more reasons I can't be a grader because I can't mark things wrong. Like, I'm like, oh, you knew what you're doing. You know what I mean? Okay. Now this one says absolute extremes. That's not relative anymore. Absolute means the highest point or the lowest point. This is what's called the candidates test. And do you remember in our notes last time we talked about extreme value theorem? And I was like, this one doesn't really show up. It doesn't show up as using, you're never going to write EVT, okay? But this is how it shows up, and we call it the candidates test. Your candidates are the endpoints of the interval. And what else do you think? What did we find on the other side of the paper? Perfect. Okay, it's the endpoints and the critical points. So you're going to start out by finding your critical points, which is derivative equals 0. Derivative equals 0. So what is the derivative of this guy? 12x squared plus 6x minus 6. We're going to set that equal to 0. Those will all divide by 6. So I would do that just to make everything smaller. It'll be 2x squared plus x minus 1. Everyone's always like, what happened to the 6? The 0 kind of absorbs it. 0 divided by 6 just is 0. That's what's nice about 0. All right, and then we're going to factor that. So that will be 2x and 1x. 1 just has to be 1 and 1. And then what symbols would we need to get a positive 1x? Yeah, good. This would be the plus 1. That'd be the minus 1. And so your candidates are 1/2 and negative 1. So here's how you do a candidates test. And I like the candidates test. And it will show up on the free response part. I have never seen an AP exam that does not have a candidates test on it. You will make a table, okay? So you're going to make a table, x, f of x. And your candidates are your endpoints and your critical points. So look back at the problem. What were the endpoints? Yeah, -2 and 1. And you could put them on there in any order you want, but I usually I try to put them smallest to biggest. Now, sometimes you get a critical point that's not on the interval, and that's kind of nice because you just toss it out. All right. I think both of these are though, right? Yeah. So we're going to have the -1 and the 1/2. Here's the thing, and this usually goes well. You have to plug it into the original function. You'll catch it if you mess that up though, because if you plug it into the derivative, what do you think you're going to get? 0. Like we literally just did that. It's what's going to give you 0. Okay. So you have to plug them into the original one. They make these non-calculator often, and sometimes it's hard to get through the arithmetic. So we're going to have to battle here. Okay. Plugging in -2, -2 cubed, -8 times 4. All right. So that'd be -32. -2 squared is 4 times 3 is 12. And then -2 times -6 is 12. So 12 and 12 is 24. Negative 32 plus 24 is negative 8. Good, we got through that one. This isn't hard, it's just tedious, right? All right, plug in negative 1. Negative 1 cubed. Negative 1, so that'd be negative 4 plus 3 plus 6. So that's going to give us 5. I'm going to be real honest. I would skip that 1/2 and come back to it because I try to save the hardest stuff for last. All right, and if you plug in 1 to the original function, you're going to get 4 plus 3 minus 6, which would be 1. All right, now let's go battle through that 1/2. 1/2 cubed, 1/8, it would actually be 4/8, which, okay, so that wasn't too bad. We're all right so far. All right, 1/2 squared, 1/4, so it would be 3/4. And then minus 1/2 of 6 is 3. Now I would just erase, if you're writing with pen, you're gonna have to recopy it. You would need a common denominator, which would be 4. So how do I write 1/2 as 4ths? Right, that'd be 2. Good. Okay, cool. I'm not having to battle through the fractions. You guys understand fractions. And then a whole 3 is perfect. Cool. I love it when I don't have to stop teaching calculus and go back and teach like arithmetic. You guys have that. It's awesome. All right, and then put that all together. 2 plus 3 is 5, minus 12, negative 7/4. And then you write the answer. That's all the work. Then you write the answer. The absolute maximum is, and what's the biggest number out of these choices? 5. At x equals, where did that happen? Now, sometimes they ask for the maximum. In that case, the answer is 5. Sometimes they ask for the location of the maximum. In that case, the answer is, so if you write it this way every time, it doesn't matter what they asked for, you will get it right. So just write it that way every time is how I coach everybody to do it. All right, and then the absolute minimum is, what's the smallest number out of that list? Yeah, -8 at x equals -2. Now here's the really cool part, and you're gonna like this. See how it says justify, but we never wrote because. The chart is the justification. So you don't have a because statement. So I really like candidates test for that reason. So you don't have to put because anywhere. All right, and then last one. I will be able to get this done before lunch. We are going to do our absolute extremes. So absolute maximums and minimums. First thing you're going to do is derivative equals 0. Perfect. Critical points. What's our derivative? Good. Typically, the derivatives aren't bad. You know how I said they always give you a messy function? Typically, for these, they don't. It'll be like, okay-ish. All right, so you would add over the 4, you get -2. You can't do a candidate's test for this one. Because what did they not give us? Yeah, that thing, like an interval, range, whatever you want to call that. They didn't give us an interval. And what are you going to do? Test every number in existence? Well, there's infinite numbers, so that's not going to work. So whenever they ask for an absolute, not relative, but absolute, you have to show that you've considered the whole number line, which is going to involve a negative infinity and a positive infinity. All right. So let's make our number line for our derivative. It's -2x minus 4. We're going to have our critical point at -2. Now you can't just fill this in negative to positive because something weird happened. Do you see how there's a negative out front? It's going to make it backwards to that. So this will be positive and this will be negative. But here, if that bothers you, give me a number that lives in this section, something smaller than -2. Humor me for a second. -5, -500 if you want. Let's do -5. Plug it in. -2 times -5. 10 minus 4 is a positive number. If you pick a number over here, it's going to come out to be a negative number. So you can always test. So during this section, f of x is increasing. Good. During this section, f of x is decreasing. So maximum or minimum? Maximum. Now that would justify a relative, but we want absolute. So we have to show we looked at the whole number line. Okay. So since, or you know what? I don't want to start my sentence that way. It should be f of x is or f of x has. F of x has absolute maximum at x equals -2 Because we are gonna have to do a sentence here because we can't do a candidates test. We can't do a table because there's no interval. Because, now why would it have to be absolute? Perfect, that's the only one. Because -2 is the only critical point. Good, don't overthink that. You guys were right. Your instincts are in the right place. You guys all have common sense. Because -2 is the only critical point, and here's where you have to show you thought about the whole number line. F prime, who is your source, is positive where? On what section? -infinity to -2. And F prime is negative -2 to infinity. That shows that it's the only critical point and you considered the whole number line. That's why it would have to be absolute. And I forgot to say something. Oh my gosh, I'm so sorry. -2 is not the maximum. It is the location of, so the actual maximum, you have to take -2 and plug it back in where? The original. I'm sorry, I forgot to put the, I remembered though, I caught it. If you take -2 and plug it in, let's see, -2 squared, 4, but it would be -4. -4 times -2 is +8 and then -7. So what's that going to give us? Then -3? -3? Okay, so I'm so sorry. F of x has an absolute maximum of -3 at x equals -2 because all that stuff.